Hello, I'm Morgan Allison, Application Engineer for Tektronix. Today I'll be talking about vector signal analysis. Although the concepts are common to almost any vector signal analysis hardware or software, I'll be demonstrating today using SignalVu-PC and the RSA 507A. Vector signal analysis is the basis for modern RF signal analyzers, and it relies on the fact that the RF signal is down-converted to baseband I and Q signals, which are then digitized over a given amount of time. Almost without exception, SignalVu-PC performs math on baseband I and Q signals to produce measurements and display data. For more information on IQ signals, see the link in the description below. Whereas traditional spectrum analyzers could primarily make measurements in the frequency domain, vector signal analyzers allow the user to make measurements in the frequency domain, time domain, and modulation domain simultaneously, at least in Tektronix products. Vector signal analysis lets the user see their signal in terms of amplitude, phase, and frequency versus time. Confirming the hot pattern of a frequency agile signal, measuring the phase shifts of a phase-modulated signal, or characterizing the behavior of signals with amplitude changes is difficult or impossible with a traditional spectrum analyzer, but it is trivial with a vector signal analyzer. Since the time domain is important in vector signal analysis, we will be talking about common visualization and measurement tools, such as amplitude versus time, frequency versus time, and phase versus time. We will also discuss the importance of controlling your acquisition time. I have created a signal with an arbitrary waveform generator that has some interesting characteristics that demonstrate the value of vector signal analysis and time domain measurements. It's centered at 2 GHz and resides within a 40 MHz span. From preset, let's set our center frequency and span to acquire the signal. I'm going to use the real-time spectrum display so I have a clearer picture of how the signal behaves, and I'll add the time overview, amplitude versus time, and frequency versus time displays. On the real-time display, we can see that the signal does not have a constant frequency or amplitude. Let's capture a stable signal and I'll give some examples. Notice our signal is jumping all over the place in both the spectrum display and all the time domain displays. This is because the analyzer is in free-run mode, where it just captures and processes data as fast as it can without reference to the presence of signals. We can use a trigger to stabilize the acquisition based on certain signal characteristics. To do this, we'll go into the Trigger menu, set the source, type, slope, and level. Once you've set those parameters correctly, don't forget to select the triggered bubble to turn the trigger on. To dig deeper, let's take a look at the time overview display. This is probably the most important display in SignalVu-PC for vector signal analysis, and if you're comfortable using it, the rest will be a breeze. Time overview controls the acquisition length and what portion is being analyzed. It shows time on the horizontal axis and signal power within the acquisition bandwidth on the vertical axis. You can think about it as an amplitude versus time display with a little bit more control. The entire window represents the amount of time captured in a single acquisition. You'll notice there are curtains in the display that correspond to the bars up above the display. The red bar is the spectrum time control, and the blue bar is the analysis time control. Spectrum time lets you control which portion of the acquisition data is being fed to the FFT engine that produces the spectrum display. Its length value is automatically set by the resolution bandwidth value controlled by the spectrum display. Analysis time lets you control which portion of the acquisition data is being fed to all the other time domain measurement displays. There are 2 notable controls here, offset and length. Offset controls where the analysis time starts relative to the trigger point, which is indicated by the small t at the bottom of the screen, and length controls how long the analysis time is. You can control spectrum and analysis time separately, or you can link them together, although I generally recommend leaving them separated and leaving the spectrum time alone unless you have some very specific needs. We can see the rising edge of a pulse in this display, but we want to capture at least one full pulse for analysis, so we need to adjust the acquisition time. The best way to do this is by adjusting the analysis time length. I can either click and drag on the length control on the right side, or type my number directly into the length field on the left side of the screen. Notice what happens to the other displays when I adjust the analysis time. Let's stop the acquisition here to illustrate the effect more clearly. In this section, we'll talk about the replay button. As I mentioned earlier, vector signal analysis relies on IQ data, and the replay control allows you to feed the data SignalVu-PC has already captured back through the measurement algorithms so you don't have to reacquire data to adjust your measurement. When I adjust my spectrum time to surround just the first pulse in my record and click replay, the spectrum display reflects the frequency and amplitude of only that pulse. When I adjust the analysis time in a similar way, the frequency versus time and amplitude versus time displays change to reflect only that pulse as well. I can add markers on those displays to check out the signal's characteristics. Note that these markers are all time correlated and they track with each other across all the time domain displays. Giving the user control of captured data is important for any successful time domain measurements, and SignalVu-PC provides this control using the time overview display. People often ask why we separate analysis time and spectrum time. We do this to allow users to separate their time and frequency domain measurements. There are tests that require a long time domain measurement while simultaneously monitoring the spectrum at a specific place in time. This video provided a basic rundown of the vector signal analysis capabilities of SignalVu-PC, including the time overview display. Thanks for watching.